Am I audible? Pritam?
Yes,
Yeah. What about the other students? Where are they?
they might be joining from second.
Okay. We will wait for 2-3 minutes and immediately we'll start. We'll wait only for 2-3 minutes for them. So I hope yesterday's problems you might have solved, and I asked you to take a screenshot of one of the problem. I hope you've gone through it. And right now, I'm not going to discuss it because I have to touch new topic, that is atomic mass, average atomic mass, how to find it out, okay, and how to find the percentage of that particular isotope, okay, in the given problem that we are going to discuss today. Right? Percentage yield, how to calculate, and what is the stoichiometry, and what is the relation of that stoichiometry with the different things like with mole, with mass, with volume, etc. That all things we are going to see in detail. Fine. Jaswant is also joined. Okay. One more child is less. Yesterday, Dhananjay
Good
was
evening,
there.
ma'am.
Yeah, good evening, Peter. How are you?
Fine.
Okay. So we'll start now. I don't know whether that other child will join or not, because yesterday was the first day and it's very difficult, like directly if you join in between to understand the concept, right? So let's hope he will join. Whenever he join, it's fine. We will start with the content. Here it is, what average atomic mass. Can you see the screen clearly? Pritam, Jaswant, both of you can see the screen or not?
Ma'am, yes, ma'am, it's visible.
Yeah, it's visible. Fine. See, now it has been found, even theoretically, that the substance, give me a minute. Yes, I'm extremely sorry. Fine. Am I audible now? Yeah. Now it has been found that the theoretically that substance can't be obtained in absolutely pure form, right? Naturally, it occurs in the form of isotopes. All of you know that carbon has 3 isotopes like C, come on, tell me, 12, C13, C14, right? These are the isotopes for carbon. If you see the hydrogen, hydrogen also have 3 isotopes. Can you tell me the name of these three? Hydrogen, that is also called as protium, atomic number 1, mass number 1. Then with atomic mass 2, it is called as deuterium, and atomic mass 3, it is called as tritium, correct?
Yes.
Yes or no? And even chlorine also exists into the nature in two different isotopic form. One has an atomic mass 35 and other has a 37. Ratio in the like nature will be 1:3. Correct? Yes or no?
Yes.
Yeah. So this is a basic thing which you have learned in your grade 8, grade 9, etc. Fine. So in such a cases, the atomic mass reported for the isotopic mixture of an element is actually the average atomic mass. Here we can't take 35 or we can't take only 37, right? In that case, you have to take what? Average atomic mass. What you have to take?
Average atomic mass.
Average atomic mass. So how to find it out that average? You have to do the summation of these two masses and you have to divide the total ratio, means whatever, how many atoms of those particular isotopic form exist into the nature. That ratio summation you have to do and you have to divide it by that. Clear? Understood? By that you can calculate the average percentage of that, means the average mass for that particular isotopic form. So here they have given formula. Please note it down. It's useful while solving the problem. Average atomic mass is equal to summation of percentage of abundance into isotopic mass upon 100. In that way, you are able to calculate the percentage because you're dividing here by 100. Clear? And only summation if you do, right, and divided by the number of atoms, then you will get what? Like fractional atomic mass. Fine. Another formula is given, average atomic mass is equal to summation of isotopic mass into fractional abundance. What is their fractional abundance? Here for the chlorine already I told you that is 1:3. Correct? So total number of atoms would be 4, correct?
4.
Yes or no? And chlorine isotopic masses would be 35 and 37. I
37.
think wrong. Ratio would be 3:1, means 3 atoms of 35 atomic mass, then there would be the 1 atom of 37 atomic mass. Correct? I gave you 1:3, but then that will be for Cl37 should be first. Okay. So now here, how you're going to calculate the average atomic mass, right? Average atomic mass would be, come on, tell me, is equal to summation. Here what we have, summation of isotopic mass. What is isotopic mass? 35, correct?
Yes.
Right? Plus here 37. Here they said their fractional abundance. What is the fractional abundance? 3:1. Means 3
Into 3
atoms of
plus 1.
35 atomic mass and 1 atom of 37 atomic mass. Divided by this summation. How much it will be? How many atoms among the 4? 3 has a 35 atomic mass and 1 has the 37 atomic mass. So I'm going to divide it by 4. Correct? Do this calculation and tell me the answer. Do it fast. 37 as it is. You just have to multiply this. 3, 5,
105.
15. Okay, carry over 1. 3, these are 9 and 1, 10. 1 not 5, right? Upon 4.
4.
This total.
142 by 4.
142 upon 4, correct? And that will be, I guess, 35.5.
Yes.
Is it? So this is what the atomic mass for chlorine, which you have to take. It is what? Average atomic mass of chlorine. What it is? Average atomic mass of chlorine. Clear? Understood?
Yes, ma'am.
This you might have learned in your grade 9. Have you heard it? You've gone through before or not? In a grade 9, you have learned it into the atoms and molecule chapter of chemistry. Yes? Are you remembering or not? Means any recapitulation is happened or not by this example? Yes, no, say something.
Yes, ma'am.
Fine. Now, so these two formulae you have to write down. This you have to use while calculating the percentage, and this you have to use while calculating the average atomic mass. Right? So,
Yes.
what next is given to you for the C? Average molecular weight of any non-reaction gaseous mixture. Right? For reaction gases mixture, we can calculate easily. But then how to calculate the average molecular weight of any non-reactive gaseous mixture? Means two gases are present, but then they are not react with each other. So how to calculate its percentage, molecular weight, right? Average molecular weight. How do we have to calculate? That we will see. For that, they have given the formula M mixture. What is this? M mixture means? M mixture means mixture of those gases, right? Molecular mass mixture of those gases. That time what you have to do? You have to do the summation of volume percentage of each gases multiplied with molecular weight. And that you need to divide with 100. This is one of the formula. To calculate the molecular mass of a mixture gases which do not react with each other. Understood? Please write it down because it's important. You have to solve several problems on the basis of these formulae. So please write down this formula, which just now, which I have explained to you. Right now, check. M mixture means the mixture of two gases is equal to summation of volume percentage into molecular weight upon 100. Now here summation means it's not regarding only one gases. Please keep it in your mind. It's a mixture. Means there may be more than one gas present. Understand? So you have to take means the volume of each gases and that you need to multiply its molecular weight and do its summation, addition, and then need to be divided by 100. You will get the average molecular weight of that particularly non-reacting gases. Fine. So one example is given to you on the basis of this. When percentage composition is given by weight, see, when percentage composition is given by weight, 100 upon M mixture, that time what you have to do? You have to do summation in bracket weight percentage upon molecular weight. Whatever weight percentage would be given to you, that would be out of 100%, right? So that's why you have to do the summation of weight percentage, and that you need to divide it by molecular weight. Okay, so you will get 100 upon M mixture is equal to summation of weight percent upon molecular weight. This is also one of the formula which is useful while calculating the percentage composition of given, when percentage composition of molecular weight is given. This much percentage of gas, that much of percentage of gas, calculate its molecular mass in percentage would be asked, that time it is useful. Or they may ask you to calculate the molecular weight of this particular compound. By giving the percentage, you have to use this formula. So one example is given to you. I request all three of you to please write it down. The problem would be what? A gaseous mixture of methane and ethane. Two gases are given here. Both are non-reacting gases. One is a methane and another is a ethane. Contains 40% of methane by volume. What is the average molecular weight of the mixture? Understanding? So,
Ma'am, repeat question.
shall I write it here? If you're not able to see in that smaller like scale, shall
Yes,
I?
ma'am.
Oh, I'm sorry. I'll write it here in a big letters, so it will be helpful for you. A sample, write down a sample, a gaseous mixture, sorry, a sample of gaseous mixture of methane and ethane. Methane is CH4 and ethane is C2H6, correct? Contains 40% of ethane, sorry, methane. 40% of methane. What are the percentage of methane? 40. Okay, by volume. What is the average molecular weight of the mixture? What you have to calculate? Average molecular weight of mixture is equal to how much? That you need to calculate. How are you going to calculate? We have a formula, but then before that, what you know, the percentage form is given, and in percentage only methane's percentages are given. Ethane percentage are not given. Okay, and total percentage of the mixture would be how much, students? 100%, right? If methane is 40%, then ethane must be how much? 60%. Then only it can become 100% mixture, correct? Yes or no? So
Yes.
in given, what you will get? First, CH4 is 40% by volume, and C2H6 means ethane must be 60% by volume, correct? And its total is 100%, correct? Now we have a formula to calculate the average molecular weight. What? Average molecular weight, that is M mixture, is equal to, for the non-reacting gases, we have a formula, summation of volume percentage into molecular weight, correct? Upon 100. Clear? Yes?
Yes.
Now here we have to do the summation. The first gas is methane, right? Its percentage is what? 40. Its molecular mass would be for methane, it how much? 1 carbon is 12 and 4 hydrogen is 4, right? 12 and 6, how many? Come on, tell me. 12 and 6, 16, correct? So 14 into 16. Volume percentage is 40. Molecular weight of the methane is 16. So 40 into 16 plus. What you're going to do else for the ethane? Ethane percentage is 60.
Into
Its molecular mass would be what? 2 carbon means 24. 12 to the 24 plus 6 hydrogen. That is equal to how much? Come on, tell me. 30?
30. 30.
So you have to multiply it by 30 and divide it by 100. Go for this calculation and calculate the terms. Let me know what would be the answer.
It's 40 plus 1,800.
But then,
40,
what would be the answer?
640 plus
40
1,800.
into 16 you have to do, and 60 plus 30 you have to do. Do the summation and divide it by 100.
Yeah.
Come on, go for it fast. Do not waste time. It's really very simple calculation. 16 fours are how much? Tell me.
64. It's 20.4.
Answer would be what? 20.4. How it will be, I'll let you know, because it's not everyone's cup of tea, right? If you're good enough in a calculation, then only you can do it. But then I feel like that if you practice, everything would be perfect, right? So regular practice is very important in chemistry, because chemistry is little volatile. Do you know the meaning of volatile? Yeah? Yes. Dhananjay, correct answer. 24.4, correct? It's given over here actually, but then I feel like you should calculate by yourself. That is very good. If you calculate, that's really good. This would be the answer. Yeah, here it is. So 16 fours are what you said, beta? 84, right? No, 64, I guess, right? Yeah, Pritam, 16 fours are.
640. 64 to 64.
Yeah, 64 and this 0 as it is, plus this calculation 20 as it is, right? 6 threes are 18, right? Upon 100. Is it? Either do this addition and then divide it by 100. How much it will be? 0 plus 0, 0, 0 plus 4, 4, 8 and 6, how much? 8 and 6, 12, I guess. Is it? No, 14. Right? Carry over 1 and that will be 2 upon 100. This 2 0 get cancelled and this point would be shifted over here. You will get 24.4. Right? Yes or no?
Yeah.
So average molecular mass would be, now this is average molecular mass, so unit you have to write AMU. Please keep it in your mind. When you calculate the percentage, that time you need to give the mark of percentile, a symbol of percentile, right? Fine. I hope you got it.
Yeah.
All of you wrote. Go for the next problem then. Okay, we were here, right? Yes. Now write down the next problem about this ozone. Ozonoid oxygen contains. Write down now. A sample of ozonoid oxygen contains. Sample of ozonoid oxygen contain 60% ozone bind, right? What is the average molecular weight? or the average molecular weight of the sample. What are you going to do in this? And why we are using the formula, this one over here. See what they gives. A sample of ozonoid oxygen contains 60% of oxygen, correct? The percentage of oxygen is given, that is 60% by weight. What is the average molecular weight of the sample? Complete sample's weight means M mixture you have to calculate, correct? But then the value which is given, that is into the percentage. And hence you have to use the second formula.